Hello, and welcome back to Summarize Science. Today, we're diving into the dramatic world of black holes that literally shred stars, and how astronomers are using these violent events to weigh the unweighable. When a star gets too close to a massive black hole, it's torn apart in what's called a tidal disruption event, or TD, producing a brilliant flare of light. For a long time, scientists have tried to use this light to measure the black hole's properties, especially its mass. The problem is, the initial flare is complex and poorly understood, leading to unreliable measurements. This new paper proposes a different approach. Instead of looking at the chaotic early flare, they focus on the later, more stable plateau phase. During this phase, the shredded star has formed a more standard, well-behaved accretion disk around the black hole. The researchers' key insight was to combine observations across the full spectrum, from UV and optical light all the way to X-rays. They showed that all this light at this late stage can be described by a single, unified model of that accretion disk. And the results are stunning. Using this method on 14 different TDs, they were able to derive black hole masses with incredible precision. Most importantly, their new measurements fit perfectly onto the established relationships between a black hole's mass and the properties of its host galaxy. This is a huge deal because it proves their method isn't just precise, it's accurate. In a major plot twist, they also showed that previous methods, which focused on that messy early time flare, do not reproduce these known galaxy relationships. This casts serious doubt on the reliability of black hole masses calculated using those older models. Essentially, by looking at the steady embers instead of the initial explosion, we get a much clearer picture. One of the coolest outcomes is that this method works for a huge range of black holes, including an intermediate mass black hole, or IMBH, a rare and mysterious class of object. This technique confirms the TD interpretation for all these sources and helps us understand the physics of how these disks form and evolve. So, let's recap the big takeaways. First, a new, highly accurate method for weighing black holes using the late-time glow of shredded stars has been developed and validated. Second, this method shows that older techniques based on the initial flare might be unreliable. This is a game-changer for black hole demographics. With upcoming telescopes expected to find thousands of TDs, this technique will allow us to build a proper census of black holes across the universe. It will help us find and weigh previously hidden black holes and finally understand how these cosmic monsters grow.